So in this video, we're still going to be graphing some exponential equations, but we are going to be taking graphs that look maybe a tiny bit more complicated. What you see in this one is not just a times b to the x, like the last two videos. We have now numbers that are being added, subtracted, or whatever, inside the exponent and out here on the ends. The good news is with those numbers, it is the usual translation rules, left, right, up, down. Inside means you're on the exponents here, so this would be a left 4, because we're adding 4 on technically what the inside is. This number right here is like your outside. This would control up and down. So I have two notes here with regards to the graphs that's going to help us. Remember I said if you don't translate an exponential, the asymptote, horizontal asymptote, is right here at y equals 0. Picture if I move my graph left or right. So here's my tail to the graph. If I move the graph left, wait, that's right, sorry. If I move it right, or if I move it left, it's not going anywhere. The asymptote is still right here at y equals 0. Left-right movement, we don't really care about that for our asymptote, our tail. But if we move up or down, that's actually going to shift where the tail of our graph goes. So when you see an equation, like take number 1 right here, the very first thing I will do is look at my up-down number. I am going down 2 on this graph. So what I'll do over here on my grid is my asymptote, if I go down 2, was it 0? Now it's at -2. So that is where the horizontal asymptote of my graph is going to go. That way I know to guide the tail of the graph along that line. I don't know which way it's going to go or where my points are, but the tail is somewhere on that green line. So what I'm going to do now is start making a table. I'm still going to use a table. But when you have your exponents with numbers in it here, it really kind of affects what numbers you can plug in. You are going to want to start where the exponent equals 0. If you do not do that, your graph is going to look like you're going to get useless points. Not useless, but weird points. So if I have x minus 5, I'm going to make sure I plug in a 5 to that equation. I definitely want to plug in that 5 so I can kind of use it to center my graph. If I plug in a 5, you would go and use your calculator and do the math or whatever. I would pretty much type that one in. I believe you're going to get out a 7 when you do that. If you plug in a 5, you should get out a 7. So I'm going to plot that point. I'm going to go over to 5, comma, 7. I'd be right there. Then I'm going to go ahead and just kind of use points close to that right here. So I'm going to plug in a 6. And if I plug a 6 into this graph, I should get out a 1. The 6, comma, 1. So I would go over to 6, comma, 1. I would put it down right there. Oh, if I plug in a 7, I think that's still going to be a whole number. I'll use that. If I plug in a 7, again, you just type it in the calculator, that is going to equal a -1. And after that, I don't have a calculator handy. I'm just going to start getting decimals. It'll be like right here, right there, and so on. So what's going to happen is this graph is really steep. Really steep. You hit your dots, and it's going to level off along my asymptote right there, because I drew that asymptote in at y equals -2. Having that dotted line there first is important, because what it does is it shows me when I'm going to tail my graph, so I don't have to plug in decimals and stuff like that. I know already it's going to tail off like that. So I'm going to go ahead and toss down the usual information here. My horizontal asymptote this time changed. It's right there. It's y equals -2. My domain, still all real numbers. My range is from the asymptote up on this one still, so it's going to be y is greater than -2. And my y-intercept isn't very easy to tell by this. My x-intercept is a decimal. Like I said, for this video, I'm not going to worry about the y-intercept. You could plug in a 0 for x, use your calculator, and find that pretty easily. I guess I'll do it real fast just to show you guys. I guess I didn't have a calculator. So I got 9 times 1/3 to the b to the -5th, and then -2. I guess our y-intercept on this graph, all I did is I plugged in a 0 for x into the equation. I typed it in my calculator. Y-intercept is 0, comma, 2,185. Just going back again to how fast these graphs grow. You can see there's no way that would have been fun to graph by hand. My x-intercepts, this time I actually do have an x-intercept. It's right there. We could plug in a 0 for y and try to solve, but I'm just going to estimate it. It's about 1, 2, 3, 4, 5, 6. I'm going to call it about, so I'll do like a squiggly, 6.5, comma 0. And that's good enough for right now. We have one more example in this video, and it's over there, number 2. I'm going to go ahead and erase this one and give myself a fresh start here. Oh, by the way, I didn't write that on this one, but that first equation, if you guys could jot that down, is exponential decay. It was going downwards like this, so it's decay. So I'll write that maybe over here for this. And again, another way I can tell it was going to be decay is because I had a fraction less than 1 right here, between 0 and 1. That makes it decrease. All right, second example of the video. I am going to put my asymptote up 6. Positive 6, that means the graph shifts up. 1, 2, 3, 4, 5, 6. My dotted line, my asymptote goes right there. Should I do that right? Yep, that's going to be my tail. So somewhere along this line, it's going to tail off. And what I'm going to do is start making points here. Again, you need to make sure you center your table where the exponent is 0. Otherwise, you're going to get weird numbers that aren't going to help you graph this. So I'm going to make sure I use -4 first. If I plug in a -4 for x, I will get out on this graph, just type it in the calculator here, we would get out a 7. So I'm going to plot -4, comma, 7 right there. I'm going to go ahead and plug in a -5. If you plug in a -5, wait, I should put that on the other side. I'm sorry. -5 is getting smaller here. If I plug in -5, that will get me out, I believe it'll be 6.2. It's going to be some sort of decimal here. So if I plug in -5, yeah, I think that's 6.2. That would be like right here. And it's going to become evident that it's leveling off right here. You could continue to plug in little decimals. But my graph is going to start like that. And I'm going to plug in at least one more number on the other side. I'm going to do -3. If you plug in -3, it looks like you're going to get out in 11. So -3 comma 11, whatever, it's right there. I would put my graph going upwards. Oh, do I actually have 11? 8, 9, 10. I do. It'd be right there. And I would just keep on going up like that. So I have my arrows on the end. That would be my basic exponential graph here. Running quickly through the pieces, horizontal asymptotes is going to be y equals 6 this time. That's where my tail goes. Domain, all real numbers. Range, y is greater than 6. It is possible to have graphs going downwards when there's a negative out front, but I'm not going to worry about that in videos. We'll just do it in class. And finally, my intercepts, I guess I can worry about later. There won't be an x-intercept on this one because it's leveling off here. There will be a y, but it's going to be really big. So that is all I'm going to do for